The standard for this video is solving real-world problems using trigonometry. You get to use a calculator. So I'll try and Alt-Tab and pull that up while we're going through so you can see what's happening. Hopefully that's not too annoying. But our objectives for this standard are solving a right triangle, angles of elevation and depression, and then similar triangles. So for solving a right triangle, we start with a note. To solve a right triangle just means to find the values of all three angles and all three sides. We use the information given to find the missing pieces. Do not round until the final step. And we can also use given information as much as possible. And when we find one of these pieces we're not given, generally we'll be rounding off, and so we want to use the unrounded given information to be as exact as possible. Recall here, the sum of the angles of a triangle is 180 degrees, so we'll have to use that to find the other angles sometimes. Generally easier than using more trig. So let's start with number one. We're going to solve this right triangle ABC if A is 28.67 degrees and B is 25.3 degrees. We're assuming angle C is the right angle. So for all these, we generally just want to start with a picture. It doesn't matter if it's accurate. We just need a triangle, or a right triangle more specifically, that's labeled correctly. We want C as the right angle. I'll just go A, B, C then around the triangle. Capital letters are generally used for the angles and lowercase for the sides, with little side A always opposite angle A, little side B opposite angle B, and C opposite angle C there. So we can label what we know, the 28.67 degrees for angle A, and the 25.3 centimeters for side B. So the easiest thing for us to find first would be angle B. We know that the measures of the angles of a triangle sum to 180. Since we've got a right triangle, we have that 90-degree angle on the bottom. So B is just 90 degrees minus angle A, right? Those two have to add up to 90 degrees as well, so the whole total is 180. So we want to get a 61.33 degrees here for angle B. And so when we are solving this triangle, it's easier to put our answer down together. So we can have in the lower left corner here, we'll put our answers and we'll put our work over there on the right. So we've got the 28.67 degrees for angle A. To go with that now, we found that B is 61.33 degrees and angle C is 90 degrees. We also know little side B is 25.3 centimeters, and we're going to find those two missing sides. So we want to use what we know. We were given angle A and side B, so we can find a relationship between angle A, and side B. If we look to our trig, we find that tangent of 28.67 degrees is equal to A over B, and B here we can sub in that 25.3 for our centimeters. If we multiply both sides by 25.3, we find that little side A is equal to 25.3 times tangent of 28.67 degrees. So if we pull up our handy dandy calculator, we are in degrees. Make sure your calculator's in degrees. We've got 25.3 times, if you can see tangent, when you hit tangent on your calculator, you want to hit that first. If you've got one like the one on the computer here, you want to get to 28.67 first, and then find and hit tangent so it evaluates what's on screen. And then we can multiply to get our side length, 13.8 here. So little a is approximately 13.8 centimeters. And then we still want to find side C. So to relate side B and side C, we're looking adjacent and hypotenuse for angle A. So that's going to be a cosine. So cosine of 28.67 degrees is going to be equivalent to 25.3 divided by side C. So we can multiply by c, which would give us a c times cosine of 28.67 degrees equals 25.3. And then divide by that cosine of 28.67 degrees to solve for c. So little c is approximately, we've got 25.3 divided by 28.67, and then I've got to find cosine, equals for my division, and I get a 28.8 centimeters. So little c is approximately 28.8 centimeters. The other thing to keep in mind from geometry, just so that we know we're not completely wrong, our smallest angle here, the 28.67 degrees, goes with the 13.8 centimeters. Our middle angle, 61.33, goes with the middle length for the side, 25.3. And that largest angle is opposite the longest side, the 28.8 there. But we have all three sides and all three angles, so we've solved that triangle. For 2, we're solving a right triangle ABC, where we're given side A is 44.25 centimeters and side B is 55.87 centimeters. So we're going to again assume angle C is the right angle. So we can draw a triangle. I'll label it the same way as I did the last one. So ABC going around, starting at that lower left corner. We know little side A is 44.25. And little side B is 55.87 centimeters. We can again put our answer over here at the end. Angles A, B, and C. We know angle C, of course, is 90 degrees. We were assuming that's our right angle. Little side A, I'll leave a little more room, probably have a decimal, is going to be 44.25 centimeters. Little side B, we were given the 55.87 centimeters, and we want to find little side C, which is our hypotenuse. So we can use our Pythagorean theorem to find that missing side length. So we have A squared, or 44.25 squared, plus B squared, or 55.87 squared equals C squared. If we take the square root of both sides, we get that little side C is approximately the square root of 44.25 squared plus 55.87 squared. Throw that in my calculator. So 44.25 squared, we're going to add that to 55.87 squared. And then we'll take the square root. We get a 71.27 since we went to 2 decimals for the others. So C is approximately 71.27 centimeters. And now we've got to find our missing angles. So I'll start with A just because maybe easier to look from that angle than from angle B. If we go back to our 2 sides that we know, we've got our opposite over adjacent. So that's tangent of angle A. So tan A is equal to 44.25 divided by 55.87. We worked with those inverse trig functions, so we could solve these. We'll have A then is equivalent to tan inverse of 44.25 divided by 55.87. When we're solving the triangles, or right triangles here, we'll always be solving for acute angles, so we should always get an angle in quadrant 1, so there won't be any negative angles. We won't have to worry about something in another quadrant. We should just be able to take what the calculator gives us. When we solve trig equations later on, we'll have to find more answers, and we'll talk about how we can get to those from the one given to us by the inverse trig function. But for this one, we just want to toss this in the calculator with tan inverse. So let's move so I can see it. We want a 44.25 divided by 55.87. And then usually under the second functions, you'll see the inverses. So you might have to hit second on your calculator and then tan inverse, or second tan inverse and then type in that fraction if you can see everything you're typing on the screen. And then we get a 38 point, let's go 2 decimals because we did it for the sides as well here. So 38.38. That's easier to remember too. So 38.38 degrees. And I know I said we like to go with the given as much as possible, but it's way easier to find angle B just by subtracting from 90, right? We know the sum of those two angles. You could try a tangent of angle B with the opposite, and maybe we can look at that quickly too just to see it, but the easiest way here would just be our 90 degrees minus the 38.38 degrees, which would give us a 51.62 degrees. And so, yeah, we can toss that in over here on the side, 51.62 degrees. And just for fun, we know that B would be tan inverse of 55.87 over 44.25. Should give us something very similar. And won't take too much longer to type in. And hey, it's a video, so you can skip if you want. But we did that division. We'll look at tan inverse here. And we get our 51.62 degrees. All right, so with that rounding, we get about the same spot there. Maybe some of the decimals further on were a little different, but we've got our 3 angles, we've got our 3 sides, so we've solved that triangle. All right, moving on to angles of elevation and depression. Note, in applications of right triangles, the angle of elevation from point X to point Y above X is the acute angle formed by ray XY and a horizontal ray with endpoint X. The angle of depression from point X to point Y below X is the acute angle formed by ray XY and a horizontal ray with endpoint X. So the important thing to remember again, both the angle of elevation and angle of depression are measured between the line of sight and a horizontal line. And I say again because all those reference angles and reference triangles we've worked with so far were in reference to the x-axis, which is a horizontal line. Now we don't always have to set these up with axes, so it's just looking up at something and then the horizontal line straight out from that point, or looking down at something along with the horizontal line straight from that point. So we're always kind of drawing a reference angle or reference triangle and coming back to that horizontal position or horizontal line where we're starting. We'll draw a couple pictures that should make sense. For number 3, we've got the angle of elevation from a point on the ground 15.5 meters from the base of a tree to the top of the tree is 60.4 degrees. We want to find the height of a tree. So we can look up. Ooh, that was a nice line, but we can look up to a tree. I'll make this my tree. Awesome tree. This is our angle of elevation, right? The ground is helping us make that horizontal. So we've got a right angle, the tree coming down vertically to the ground. The distance from the base of the tree, we were given 15.5 meters. And the angle of elevation was 60.4 degrees. So again, we just want to think of what trig function relates the height of the tree here, the side we want to know, and the information we're given. Again, that's going to be tangent. We can see the opposite and adjacent sides for 60.4. So all we need here is tangent of 60.4 degrees is equivalent to x over 15.5. And if we multiply by that 15.5 on both sides of this equation, we will solve for x. So x is going to be equal to 15.5 times tangent of 60.4 degrees. So with our calculator again, if I can find my cursor, we're going to put in 15.5 and multiply by, I've got to hit the 60.4 and then tangent, and then equals to do my multiplication. I get a 27.28 or 27.3, if we round to 1 decimal, like we were given. So 27.3 meters. And for word problems, we like word answers. So we can say the tree is 27.3 meters high, tall, whatever you want to write. All right, for an angle of depression. For 4, find the angle of depression from the top of a 97-foot building to the base of a building across the street located 42 feet away. So we want to start with a tall building. Not going to be a great drawing for me, but we can represent a building here. Maybe more windows to make it fun for you. That's 97 feet tall. And then we want another building 42 feet away. Make him look like he's yelling. All right, our angle of depression is from the top of the first building to the bottom of the second. The angle is made by that horizontal line out from the top of the building where we were starting to look down. And then a little bit of geometry can help you here. We've created a rectangle. Our horizontal line looking out should be parallel to the ground, and the buildings are both vertical, so should be parallel to each other. So we get a 42 along the top here, and a 97 up that side as well. You may also remember hearing in geometry that alternate interior angles are congruent, so we could also work with the fact that this angle down here is the same as our angle of depression. So the angle of elevation looking up from the bottom of this building to the top of the one we're supposed to be on. And either way you look at that, our opposite side is 97 and our adjacent side is 42. So we can say that tangent of that angle theta is equal to 97 over 42, or theta equals tan inverse of 97 over 42, and then get an approximate value there. So we've got 97 divided by 42. We're going to get that value and then toss it inside our tan inverse. Comes out to a 66.6 degrees for our angle. So the angle of depression is approximately 66.6 degrees. All right, and we can go on to some similar triangles. Recall, two triangles are similar if their corresponding angles are equal, or you can put congruent if you remember that word, and their corresponding sides are proportional. So for 5, if a tree casts a 24-foot shadow at the same time that a yardstick casts a 2-foot shadow, we want to find the height of the tree. Since we are on the ground looking up at the same sun, these angles of elevation in the lower left corners are going to be the same. We also have right triangles. The yardstick and the tree are standing up. And if 2 of those angles are the same, then the third angle has to be the same as well. So we have our similar triangles. We can use a proportion then to find the missing side, the height of the tree here. We want to set up a 3 over 2 equivalent to x over 24, so that we have the height of the yardstick or tree in the same spot, the numerator, and the length of the shadow in the denominators. To solve this one, all we have to do is multiply by 24 to isolate the x. If we multiply the 24, we know 24 divided by 2 is 12, and then 12 times 3 gives us 36. So the tree is 36 feet tall. And for 6, we have a 6-foot tall person walks away from a 10-foot lamppost. What's the length of their shadow when they're 10 feet away from the base of the pole? So if it helps, we can draw 2 triangles here. We have a big triangle that should match the figure as exact as I can draw it. We know the height of the flagpole or the lamppost here is 10, and we have a base of 10 plus x, right? We're 10 feet away, and the shadow is represented by this x feet long, so the whole length of that side would be 10 plus x. We also have the smaller triangle made by the figure and their shadow. So it's a 6 foot tall person with an X foot long shadow. We know that these triangles are part of the same triangle here. So that lower right corner is the same. They also have the 90-degree angle. And if two of those angles are the same, and we subtract from 180, we know that that third angle is going to be the same as well. So they are similar triangles. We can set up our proportion similar to the last one. I'll use the base of the triangle over the height. So x over 6 is equivalent to 10 plus x over 10. Since we have equivalent fractions, we can cross multiply here. We can multiply the 10 on both sides to really get that 10 times x, and then the 6 on both sides to get the 6 times 10 plus x. So we end up with a 10x equals 6 times 10 plus x. I'll move it over just so I don't have to move the screen. We get a 10x then equals, when we distribute in, I'm going to write it as a 6x plus 60. Subtract our 6x to get it over to the left side. We end up with a 4x equals 60. And when we divide by 4 to solve for x, we find that x is 15. And so we can write a sentence here at the bottom and say the person's shadow is, I hope it's feet because I'm going to write 15 feet long. Yeah, 6 feet tall. We definitely got feet. So we want to make sure our units are the same as what we started with, but we've got a shadow here that's 15 feet long. That's the end of the notes, so try the ticket, come with questions.